All right, so let's keep going. All right, so let's keep going now with this. So we get all the way down here, right? 28x plus 13 equals 6 times x plus 4. So now what we want to do is solve this equation. Okay, so again, here what you want to do, remember, you want to get x all alone on one side. Okay, I mean, there's more than one way to accomplish that. So you don't have to take the same exact steps that I'm taking. You do have to use those manipulations from last time. So for instance, here's one way to do it. I subtracted 13 from both sides, right? As you can see. Now, how's that help? Well, on the left side here of the equal sign, the 13's cancel. We're left with 28 times x. Then we have the equals here. Then we have 6 times x over here, as you can see, minus 9. Okay, that's good, good. Now, what can we do next? Well, again, we want to get x all alone on one side. So I'm going to subtract 6 times x from both sides, right? So on the right side, the 6 times x is gone. 28x minus 6 times x, that's 22 times x. So that's what we get here. So we have 22 times x equals negative 9. Almost there. We don't want 22x though. We want x. We want x. So we divide both sides by 22, right? And that kills, and then on the left side, we're going to get x all alone. And we get x equals minus 9 over 22. Again, we divided both sides by 22. That gave us x all alone on the left side. And what's left over on the right side is minus 9 over 22. So we get minus 9 over 22. And that's our answer. All right. Any questions? Okay, so any questions on this? Good. All right. Okay, so let's do another one then. So for this one, we have this here. Now, we have denominators 7, 3, and 7. So here, we're going to get the denominators for only 7 and 3. We're going to get, the least common multiple of just 7 and 3. So let's do it. Okay, so again, we're going to have to start listing. So we have 7, 14, 21. I mean, you could keep going, but we know 21 is a multiple of 7. Okay? But let's make sure there's no other multiples that work. So let's list the multiples of 3. We have 3, 6, 9, 12, 15, 18, 21. And you can see that the only number, the first number in both lists is 21, right? Nothing earlier than 21 is a multiple of the other number. In other words, the only number in both lists that we have here is 21. So 21 being the first number that appears in both lists, you know, the multiples of 7, multiples of 3, 21 is the least common multiple of 3 and 7. So what we're going to do is multiply both sides here by 21. Again, there's really more than one way to solve these. You could multiply both sides by 7 times 7 times 3, which is 21 times 7. I think that's 147. But, you know, that's going to be a lot bigger. Then you're going to get numbers that are much bigger. So that's why I think the LCM is better, because, you know, it's a little bit easier to work with. All right. So let me just get rid of this so I can show you the work. Just getting rid of these so we can show you the work. All right. Okay. All right. So here we have this. So we have this equation. We have the least common multiple. Okay. So now, which is 21. So what we're going to do is we're going to multiply both sides by it. And then we're really going to proceed like we did with the previous example. You know, we're going to first distribute like so. That's what we do first, right? And once you distribute, we get the line below it. Okay. So now we're going to have some cancellation. Namely, we have 7 and 21. Well, 21 divided by 7, that gives us 3. So the 7's gone. 21 becomes 3. Okay. From here, we have 3 and 21. 21 divided by 3 is 7. So this cancels. The 3 cancels, that is. We get 7. Like so. And over here, we have 21 over 7. Well, again, just like over here, the 7 cancels and 21 gives us 3. Good. Good. All right. All right, good. Okay, so now, once we do that, we get the line below. You know, now the denominators are gone, and that's really the hard part, eliminating the denominators. Now the rest is just routine equation solving. So for this 3, we're going to distribute, right? Because we're multiplying, okay? And that gives us here, we get 6x minus 9. From here, we get 7 times x, which is 7x, minus this, which is minus 7. 3x times 3 is 9x. Okay. So now we have that. So we have this equation. Okay. Now how do we solve this? Well, notice there are like terms we can combine, right? Like terms we can combine. Namely, we have 6x and 7x. We can combine. We can put those next to each other. Minus 9, minus 7. Put those next to each other. And we have equals 9x. Okay? And so from here, what we get is 13x, right? That's when you combine these two like terms, 6x and 7x, minus 9 minus 7, that's minus 16, and we get 9x. So we have that equation to solve. Okay, almost there. Okay, so we're doing good. From here, what do we get? Well, we have 13x minus 16 is 9x. Again, we want to get x all alone on one side. Okay, that's what we want to do. We want to get x all alone on one side. So that's what we want to do. Okay, so there's more than one way to approach that. We subtract 13x from both sides. This is one way to do it. Minus 16 is here. Minus 4x is here. Okay. Now, I like to have x on the left side, so I interchange both sides. So we have minus 4x equals minus 16. So from here, then we want to get x all alone, right? So we divide both sides by -4. The -4's cancel, we get x. Here we have 4. X equals 4. So 4 is our answer then. So that's what we get here. Okay. So the answer to this here is 4. So 4 is our only solution. Are there questions on this? Good. Any questions on this? Oh, come on. There we go. All right, so let me, I do have a worksheet. It's a short worksheet. I figured it'd be good for people to work on. So let's keep that. All right, so let me share that now. Let me stop sharing this. There you. There it is. All right, let me share that. It's going to share it. Here it comes. There it is. All right, so here's just a worksheet where you guys can practice. Okay, should take about 5 minutes or so. So I'm going to stop the recording